For the first iteration, I started with the red wins 3000 BC test. When I initially implemented this, I was hard coding stuff in the game impl file. So in game impl, I had return or get winner, always return player red, which is how it is still functioning. And then when I had get age, this was before we implemented age, so it was just hard coded to negative 3000. Now that we've implemented aging, we will get the age, and then these check treasury functions are not part of the red winning. But as we decrement the age and it gets down to 3000 BC, we make sure that get winner is still player red, which is returning true. I also worked on blue being in turn after red. So initially we wanted to check to see that red was always the player in turn. So initially this was just returning player red. From then we changed the test to alternate using the end of turn function. So we added a private variable called turn, which just keeps track of whose turn it is. And then in the end of turn function, it always increments. So then in the get player in turn, we use the modulation function here to determine whose turn it actually is. So now we can implement both the blue player and the red player. So now in the blue turn after red test, after we get the player in turn, we call end of turn, and then we continue this cycle alternating between the red and blue player being in turn. From then, we worked on the population size always being 1. We had some struggles with the get city at function. So to go about that, I implemented the city interface here by creating a constructor which takes in the city position and the city owner. So now in the game impl file, we have a private position variable for both the red and blue city at their respective locations, and then a private city variable for both the red and blue city, which takes in the argument of the position and associated player. So now when we go down to this turn, or to this test, using the getCityAt function, we make new positions that return null values, and we call the red and blue city position respectively and make sure that they're not null values.
Okay, so for the first iteration, I implemented these 3 test cases right here. So ocean being at position 1, 0, the red player cannot move the blue player's units, and the unit cannot move over mountain, so any unit. So to start, ocean at position 1, right here is just a position, placing this ocean at 1 to test this out. So in the tile impl file, basically this constructor right here creates a tile and just gives it this string tile type from the game constants file. So if we go over here to game impl, up here we have a tile ocean with that tile type of ocean, and then as we are implementing these tiles, the get tile at function returns the tile types. So these test cases, like sort of the ocean and the mountain, are sort of similar. So they both use the get tile at function, which based on the row and column of these tiles, it either will return the ocean or the mountain. For now, since there's only one ocean, one mountain, it's just sort of hard-coded with their locations on the board. For each of this ocean and the mountain, we created a private variable with just that string type for that tile. And then this goes through, checks if the for the oceans, checks if that tile at position 1, 0 is an ocean. And then for actually the unit cannot move over mountain, the move unit function in the game impl file down here, first of all, heading into the unit impl class. The constructor takes in the unit type, same from that game constants file, and then an owner, which is a player type. So in the game impl move unit, first it checks if this unit at the position that the player wants to move is actually the player in turn. So this function right here, red cannot move blue. It cannot move blue's player if it's not the owner of that unit. And then the move unit also will return if it's a planes. So at the moment, units can only move if they are going to a planes tile. So this test that units cannot move over mountain should pass. So if I go ahead and run this, we can see that 7 out of 7 test pass. So all three of these do work.
One, I'm going to take you through what I worked on. So starting out, I worked on this get age function. So we start in game impl. We have the age as 4000 BC. That's why it's negative 4000. And I'm going to go down to here where it's the end of turn. So after red goes, turns implemented. Or turns incremented by 1, and then after blue goes, it's incremented again. So that's the end of the round. So then we add 100 to show that 100 years have passed. And so that's in the test case. We just have it going by 100 for each of these tests. The next that I worked on was the get treasury function. So I can take you over to that, which is right here. It's going to add 6. That's just like the hard-coded value that was given for the instructions. So this just goes and gets red city and add production. And so I have that function for add production in city impl file. We weren't allowed to use the mutators. Therefore, there's no mutators in the city file. So in the implementation, I have the add production, which just takes in what needs to be added, so when in the future we can change that value, and then just adds it to the city currency, which is this value here. And I also added in the subtract production. This will be used in iteration 2. That's why there's no usages there. And then I will show you this, the test file for the get treasury. It just implements 6 each time after each round, so that's why I'm implementing red and blue city, and then just checking that it added 6 until the very end. So I'll go ahead and run this for you, just to show that all the tests have passed, and there you go, 7 out of 7, so nice.